Uh, Thank you. You are welcome to the last lesson, which is lesson 5, which is about chi-square. So to start with, let's have the chi-square formula. So chi-square, note that it is not chi-square like some people would say. It is chi-square. So it's represented by this symbol. So chi-square is equal to summation O minus E all squared all over E. So that is the formula for chi-square, and that's pretty looks pretty simple, but could be complicated at times, though it's doable. So just put your mind there and you'll get it solved. So we have some things here. By now we are well familiar with, we should be acquainted with this symbol, which is summation, and that is the addition of all of this. So that is the implication. Now we have E. O here means observed frequency. E means expected frequency. So meaning that chi-square is all about getting to know the difference between the observed and the expected frequency. And what do we mean by observed and expected frequency? Let me take this example. You will remember during your when we were all kids, you remember sometimes when your parents receive visitors, even using our own as an example. So when your parents receive visitors, and when the visitors is about to leave, they give you money that, oh, take, go and share this with your brothers. Maybe the visitors has take a sample of your family and so notice that you have there are 4 children, meaning yourself and 3 other. Maybe you are the elder children, you are the elder child, you are the eldest child. So, and you have 3 other siblings who are younger than you, who are your younger siblings. So, and the visitor felt, oh, they are 4, let me give them 4,000 naira. Or let's say the visitor give you 1,000 naira. 1,000 naira. You remember then 1,000 naira was a lot of money. So the visitor gave you 1,000 naira. Since you are 4, he was expecting that you would share it at the rate of 250 naira per child. 250 naira per child. And that was what he thought when he gave you 4,000 naira. Or like nowadays, that the money has really lost its value. So let's assume you receive a visitor and he now wants to leave and he gives your children money, and he has taken a sample of your family, of your household, noticing that you have 4 children, and say, okay, these 4 children, let me give them something. And he dipped his hand into the purse or pocket or wallet, and he gave your children 4,000 naira, expecting them to distribute it to share it as 1,000 naira per child. That 1,000 naira per child. So that is the expected frequency. So what the person expects that, oh, there are 4 children, so if I give them 4,000 naira, they will share it at 1,000 naira for each of them. But here you have your eldest child, maybe 15-year-old, and the next one is say 12-year-old, and the next one is maybe 8 year, and the last born is just say like 4 year. 4 year. So as the eldest child will start doing the mathematics. Oh, okay, let me start from this youngest child, the junior of the house. I'm going to give him or her 500 naira. The one that follows him, I will give him or her say 750 naira. And the one that is next to me, if I remove anything from his own 1000 naira, there might be an issue. So he may just decide that I'm not going to remove from his 1000 naira. And not just that I'm not going to remove from his 1000 naira, so that he will not also report that I gave this the youngest 500 and this 700. I will also add something to his own 1000 naira. So let me give him, or let's say this one was given 700 naira. So let me give this 1200 naira. 1200 naira. So it means he has his own 1000 naira. He has 500 naira surplus there. He has 300 naira surplus there. Out of the 300 naira surplus there, he has given 200 naira to this. Then it remains 100 there, 500 there. So here he is taking 1600 naira. So this is the observed frequency. That is what actually transpired. So that's the observed frequency. The expected frequency is 1000 naira per child. So the observed frequency is the reality. So 1006 for this, 1002 for this, 700 naira for this, and 500 naira for this. So that is the similitude of expected and observed frequency. So chi-square is all about finding out the difference between observed and expected frequency. So let's take an example. So it has a simpler form and a complex form. So we are going to take the complex form because the simpler form is not likely to come in an exam. So for instance, the simpler form, we can even use what we have now. Okay, that is, we have 4 children. This is observed frequency. This is expected frequency. And this is observed minus expected. And this is observed minus expected all squared. And next to it we have we have observed minus expected, observed minus expected all squared, and we have observed minus expected all squared divided by E. So observed is 1006 followed by 1002 followed by 700 naira and lastly 500 naira. Expected is 1000, 1000, 1000, 1000. So this minus this 600, this minus this 200, this minus this minus 300, this minus this minus 500. By the time you total this, you must get 0, especially for the simpler form like this. So this squared will be 36 . 0 0, and this square is 4 0 0 0 0. This square is 9 0 0 0 0, 25 0 0 0 0. So then you divide this by 1000. So this will give us 360. This will give us 40. This will give us by 1000 360, yes. This is 40. This is 90, and this is 250. So summation of this is 400 plus 90 plus 250, that is 740. So our chi-square will be equal to 740. So now let's quickly take an example for a complex chi-square, which is what we need for the exam. So I think I saw a question here the other time. Hello? Yeah. So there's a question here, which is chi-square. The question is this: a researcher administered, that is exam question, I think, first 2022-2024. That's last session. So the question is this: a researcher, number 3, that's 3B, a researcher administered the scale attitude of examination malpractice to a random sample of SS1 students from the 3 socioeconomic background and obtain the following results. So when you see question like this or table like this, you know that no doubt it is chi-square. If it is t-test, you only have for x and x, then you have y. The same thing for correlation. But for t-test, for chi-square, you will always have a more complex value. So socio-economic status, then we have the positive, moderate, and negative. So we have the values. So we have on here, we have low, medium, high, and we have here 48, 12, 8, 24, 20, 18, 35, 10, 25. State the appropriate research question and suggest a suitable null hypothesis. So the same way like we have done in the past in t-test and correlation, a research administered scale attitude of examination malpractice. So here we can say what is the difference between examination malpractice score of students in low, medium and high socioeconomic status area? Or then the hypothesis will be that there is no significant, or we can also say there is no significant effect of students' socioeconomic status on their examination malpractice tendency or score. So that is briefly on that. So let's quickly look at this because we don't really have much time again. So let's quickly look at this. So this is the formula. We need observed and we need expected. These are the observed. These are the observed. So our expected frequency is equal to column total times row total all over grand total. That is the expected frequency. Column total times row total all over grand total. So let me move this a bit. Let me move this down. Expected frequency is column total times row total over grand total. So, like we do have the need for this, we have a total of 9 numbers. So, we need to shift this. So this will be our observed, then followed by our expected. Okay, like I do encourage to avoid mistake, we can okay, let's have our observed, our expected, then we have our observed minus expected, we have our observed minus expected all squared, and we have our observed minus expected all squared all over expected. So for our observed, let's start listing them. We can list them in whatever form. You can list them on row, or you can list them following the column. So like I can say this, then this, then this, then this, then this, then this, or this. I can use whatever format. So we all arrive at the same answer. So let's take based on row. Based on row now. That is this is row. Why this is column. So we have 48, 24, 35, 12, 20, 10, 8, 18, and 25. So now, to get our expected frequency, our E, we need column total, and we need row total, and we need grand total. So this will be done by this. Our row total here, our row total here, this is 48 plus 24 plus 35. That is equal to 107. We have total here, and we also have total here. That's the column total. So we also have 12 plus 20 plus 10, that's 42 here. And we have 8 plus 18 plus 25 here, that's 51. Then let's do the column total. 48 plus 12 plus 8, that should be 68. Then 20 plus 24 plus 20 plus 18, that is 62. Then 35 plus 10 plus 25, that is 70. Then the grand total will be total of this. So by the time you total this, what you get here should also be the total for this. So it's the same grand total. So let's do this first. 107 plus 42 plus 51, that gives us 200. Let's check this, the row total, the total from this, from the grand total, from the column total. That's 68 plus 62 plus 70, that's also 200. So that is why whatever you get here must be the total for this and also the total for this. If the total you get here is different from the total you get here, then you should know that your answer or your calculation is wrong somewhere. So like I said, we got this by getting the total. This plus this plus this give us this. This plus this plus this gave us this. This plus this plus this gave us this. Then coming here, this plus this plus this gave us this. This plus this plus this gave us this. This plus this plus this this plus this plus this gave us this, and this plus this plus this gave us this. So this is the grand total that we have here, GT, grand total. Then the column total. Now we have the column total here. This is column, this is another column, this is the third column. Then this is row 1, row 2, row 3. So this is the row total for 2, row total for 3. So for each of these observed frequency that we have here, for each of them that you pick, it will have a row total and a column total, then the grand total. So let's see. If we pick this 48, for 48 that we have here, the row total is 107. So that will give us 107 times the column total. Let's start like it is written. Column total 68. That is 68 times row total 107 divided by 200. So what is that? 68 times 107 divided by 200. That is 36.38. So that's our expected here. 36.38. So we do the same thing for the next one, which is 24. 24 here. So this is the 24. So the row total, the column total is 62. That's 62 times row total 107 divided by 200, grand total. So what will that give us? 62 times 107 equals this, divided by 200. That is 33.17. The next is 35, which is the last on that row. Okay, you don't even need to clean it. 35. The column total is 70. 70 times 107 divided by 200. 70 times 107 divided by 200. That's 37 17.45. So now we move to the next row, which is this second row. So this is row 1, row 2, row 3, column 1, column 2, column 3. So we move to the second row, which is 12. So for 12, the column total is 68. So we have 68 times row total 42 divided by 200. 68 times 42 divided by 200, 14.28. So we just need to erase this. For 20, which is this, the column total is 62 and the row total is still the same thing. This is also the same thing. So 62 times 42 divided by 200, 13.02. Then we have the last one, 10, the same row. So the same row total and the same grand total. The column total is what we change. That's 70. 70 times 42 divided by 200. That's 14.7. That's 70. Then the next is the last row, which is this, 8. So the row total, the column total is 68 times row total 51 over 200. So 68 times 51 divided by 200, 17.34. Then the next is 18. So the column total is 62. The row total is the same, 51, and the grand total is the same. 62 times 51 divided by 200. That's 15.81. Then the last is 25. Column total is 70. And the row total is the same thing, 51. So 70 times 51 divided by 200, 17.85. So that is that. So now the next, you can see that is simple. So the next is this, O minus E. So let's start. 48 minus 36.38. That is equal to 11.62. 24 minus 33.17 equals minus 9.17. 35 minus 37.45 minus 2.45. 12 minus 14.28 minus 2.28. 20 minus 13.02, that's 6.98. 10 minus 14.70, that's minus 4.70. 8 minus 17.34, that's 9, minus 9. Minus 9.34. 18 minus 15.81, that is equal to 2.91. 2.19 rather. 2.19. So then 25 minus 17.85, that is equal to 7.15. Then we also need to check if this is correct. So what the easiest way to check is, if you add the last two digits here, this decimal number, to this one, it must give you 100. If it doesn't give you 100, then there's mistake in your calculation. This plus this is 100. So that is for the ones with positive, the positive integers. The positive integers now. You will see that we have positive and we have negative integers. So for the positive integers, if you add this and this, it must give you 100. So this is 100. The next positive integer here is this. So 2 plus 98 is also 100. The next is this. 19 plus 81 is also 100. And lastly, 85 plus 15 is also 100. And for the negative integers, what you have here as the last digit, the last two digits here, must also be the last two digits here. So look at this. 17. The next is this. 45. The next is this. 28. The next is this. 70. The next is this. 34. So that is an easier way to check quickly whether you are on the right track. So now we have to square this. The square of this, 11.62. 11.62 square equals, so like I said in the previous lessons, that when you are squaring numbers like this last digit, take the square of it. This is 2 raised to power 2, which is 4. So whatever you get here as the square of these numbers, 11.62, must end with 4. If it doesn't end with 4, then there's a problem. So let's see. 11.62 squared gives us 135.0244. You can see 9.17 squared. 7 squared is 49, so it must end with 9. We have 84.0889. 2.45 squared. We have 6.0025. That is 5 raised to power 2, 5 and 25. So it must end with 5. So this is 64. It must end with 4. So 2.28 squared. That is 5.1984. Then 6.98 squared is equal to 48.7204. Then 4.7 squared equal to, here the last digit is 7 that we are considering, so it must end with 9. So that is 22.09. So then 9.34 squared, it must end with 6. That's 87.2356. 2.19 squared. This is 9 raised to power 2, 81. It must end with 1. So that is 4.7961. And this must end with 5. 7.15 squared equal to 51.1225. So at this point, we divide this by E. So don't go and make the mistake and say you want to sum this and now divide by E, expected frequency, because the expected frequency here is not the same thing. So let's take note of that. So this is this divided by this. So let's start. For the first one, we have O minus E squared. That's 135.0244. Another thing you can do to fast track your process is that while you are doing this, you can do this simultaneously. The moment you get the answer here, you divide by E and put it here. So that will make it faster. So this divided by 36.38, that is 3.7115. Then 84.0889 divided by 33.17 is equal to 2.5351. Then 6.0025 divided by 37.45, that is equal to 0.1603. Then 5.1984 divided by 14.28, that's equal to 0.3640. Then 48.724 divided by 13.02, that is equal to 3.7419. Then we have 22.09 divided by 14.7, that is 1.5027. Then 89.2356 divided by 17.34, that is equal to 5.1462. You can also be doing this to cross check whether there's a mistake along the line. So we have the next is 4.7961 divided by 15.81, and that is equal to 0.3034. And lastly, 51.1225 divided by 17.85, that gives us 2.8640. Wow, fantastic. So now the summation is this. Let's do the summation, the addition of all this. By the time we get the addition of all this, then that is our chi-square calculated. So it's very straightforward, though it could be complicated if care is not taken. So you have to be very careful when solving this. So now let's see. Look at the last digit here. 5 1, that's 6, plus 3, that's 9, plus 9, that's 18, plus 7, that's 25, plus 2, that's 27, plus 4, that's 31. So it means that by the time we sum it up, the last digit of the summation must be 1. So let's see. 3.7115 plus 2.5351 plus 0.1603 plus 0.364 plus 3.7419 plus 1.5027 plus 5.1462 plus 0.3034 plus 2.8640. Great. So it ends with 1 as expected. So that is 20.3291. That is our chi-square calculated. So our chi-square calculated is equal to 20.3291. So to now get our chi-square critical, so we need our significance level, which is usually 0.05 as said in previous lessons. Then our degree of freedom here, let me put it somewhere here. Our degree of freedom is equal to row minus 1 multiplied by column minus 1. So let's see, how many rows do we have? We have 1, 2, 3. How many column? 1, 2, 3. So that is invariably 3 minus 1 multiplied by 3 minus 1, and that is equal to 2 times 2, which is equal to 4. So our degree of freedom is 4. So let's go to our table to check for chi-square value. So we want to check for chi-square value. This is Pearson. This is not also chi-square. This is not chi-square. This isn't it. Yes, here it is. We have our chi-square from here. So you can see that this is the degree of freedom. Our degree of freedom as shown on the board is 4. That is 3 minus 1 times 3 minus 1, 2 times 2, that is 4. Our level of significance is 0.05. So let's check. So we check 4 under 0.05. This is 0.05. That's the fourth column. So let's see. 4 here. So that is it. That's 9.49. 9.49. So our chi-square critical is equal to 9.49. 9.49. As a result, this is our conclusion. Since chi-square ka, which is 20.3291, is greater than chi-square critical, which is 9.49, we conclude that H naught is rejected. H naught is rejected. So this brings us to the end of the lesson. Thank you all for staying with me to the end of this lesson. I wish you and myself remarkable successes in our exams. So, like I said at the beginning, feel free to share these videos with students within and outside UNILAG who are in need of these explanations. So I hope it's going to be beneficial for all of us. So, and in case you maybe you are practicing it, or you have one or two things to clarify on the explanation or on any of this analysis, you can reach out to me on WhatsApp via +234 81 034 874 55, or you mail me at Mukaila, that is TA, at gmail.com. So you can reach out to me either on WhatsApp via that line or on that email address. Thank you for staying with me. I wish you all best of luck. Bye.